Hello everyone, I am Dr. Godan Raman, Assistant Professor Senior Grade, Department of Mathematics, Faculty of Engineering Technology, SRM Institute of Science and Technology, Kattangaluttur. We are going to discuss the topic queuing theory in this session. This topic covers UG level, BE, B.Tech, B.Sc and PG level, ME, M.Tech, M.Sc, M.B.A and so on. Fundamental of queuing theory. A.K. Erlang in 1909 he published first article, The Theory of Probabilities and Telephone Conversation. All of us has experienced the irritation of having to wait in line. Look at this picture, customer arriving for service. If the server free, the arriving customer gets service immediately. After the service completion, the customer leave the service area. If the server is busy, the customer join and wait in the line. For example, we wait in the line in traffic jam, toll booth, petrol bunk, ticket counter, college canteen, supermarket and so on. Why then is there waiting? There is more demand for service that there is facility for service available. Why is this so? There may be a shortage of available server. There may be a space limit to amount of service that can be provided. Queuing theory is a powerful tool for modeling many practical applications. Still now the queuing theory we are studying, we are experienced practical application wise in queuing system. But still the queue is not reduced because we are facing everywhere queue, waiting in line. Then what is the role of queuing theory? I just compare with some example. Media. What is the media? Nowadays radio, TV, newspaper, YouTube, WhatsApp, Facebook, Instagram and so on. These are the medias. And nowadays media is a powerful one. Media is solving any issue directly. Then how is media powerful? Then what is the role of media? If any issue, the media live telecast to the people. Based on that, the concerned person will solve the problem as soon as possible. Similarly, the queuing theory is a powerful one. It will answer the following question with mathematical analysis. One is, how long must customer wait? How many people will form in the line? These two questions answer the queuing theory. Characteristics of queuing theory: arrival pattern of customer, service pattern of server, queue discipline, system capacity, number of service channel, number of service stage. These are the characteristics of queuing theory. Customer. The term customer is used in general sense and does not imply necessarily a human customer. Example: an aeroplane wait in line to take off. A computer program waiting to be run as a time shared basis. Arrival pattern of customer. This is our customer behavior. The customer may be single, bulk or batch, bulked customer, reneged customer, and jockeying customer. Bulk or batch, and before that single. If single means only one customer arriving for service, a single customer. Bulk or batch, more than one arrival can be entering the system simultaneously. The input is said to occur in bulk or batches. Bulked customer, if customer decide not to enter the queue upon arrival, he is said to have bulked customer. Reneged customer, customer may enter the queue but after a time loss patient and decide to leave. In this case, he is said to reneged customer. Jockeying customer, two or more parallel waiting line, customer may switch from one to another. This type of customer is jockeying customer. Service pattern of service. If system empty, the service facility is idle. Service may also deterministic or probabilistic. Service may also be single or batch. One generally think of one customer being served at a time by a given server, but there are many situations where customer may be served simultaneously by the same server. The service rate may be depend on the number of customer waiting for service. The server may be work faster if sees that the queue is building up, or conversely, he may get flustered and become less efficient. This situation in which service depend on the number of customer waiting is referred to as state dependent service. Example: customer with a computer with a parallel processing, people boarding a train. Queue discipline: first come first serve or first in first out. First come first serve is nothing but who is coming first getting service first. So this is a first come first service. This is the only we are following regular basis. Last come first serve, who is coming last getting service first. So this type of cases, last come first service. For example, look at here bangle. So last bangle only we removed first. So last come first out. Random selection for service. In this cases the queue will not form because of the appointment based on the service will provide. Therefore the random selection service the queue will not form. Priority. Priority we have two cases, primitive, non-primitive. So primitive we consider some hospital. Primitive is the customer with the highest priority allowed to enter the service immediately, even if customer with lower priority is already in service when the higher priority customer enters system. Non-primitive, the highest priority customer goes to the head of the queue but cannot get into the service until the customer presently in the service is completely, even though this customer has low priority. System capacity, finite capacity, infinite capacity. Finite capacity is nothing but a queue with limited waiting room, so that when the time reaches a certain length, no further customer are allowed to enter until the space become available by a service completion. Infinite queue with unlimited waiting room. Number of service channel, single channel system, multiple channel system. Single channel system, customer arriving for service. If server busy, then the customer wait in the line. If server is free, then customer get the service immediately after the service completion. The customer leave the service area. This stage is single channel system. Only one counter they are involved. Multiple channel, two or more channel. It's a more counter is involved for this system. It's a multiple channel system. Example, barber shop, supermarket, ticket counter. Number of service stages, single stage, multiple stage. Single stage is nothing but only one process, the customer arriving for service, getting for service and leaving for service. So arrival, queue, server once providing the service, then departure after the service. This is only one stage. But multiple stage and one single stage, example, barber shop, supermarket, theatre, whatever we consider single stage. Multiple stage, customer arriving for service, they are waiting in the queue. After service completion, they are join another queue, again getting the service, then departure after the service. For example, medical history, account opening, canteen, we are consider this example. Candle notation, A, B, X, Y, Z. A is nothing but inter arrival time. M, we use some notation M, exponential, D, deterministic, AK is Erlang type, and HK hyper exponential type, PH is space type, G is general. Similarly, B is a service time. Again we used M exponential, T deterministic, AK is Erlang type, and HK hyper exponential type, PH is space type, and G is general. X is number of parallel server, single server, multiple server, and Y system capacity is a finite capacity or infinite capacity. And Q discipline, first come first serve, last come first serve, random selection service, priority, general. And queuing model, three category we used: probabilistic or stochastic model, deterministic model, mixed model. Probabilistic model is nothing but when there is uncertainty in both arrival rate, service rate, and are assumed to be random variable. Deterministic model, both arrival rate, service rate are constant, exactly we know earlier. Mixed model, when either the arrival rate or service rate exactly known and the other is not known. Thank you. So next video we are going to discuss with problem based on.